Assalamualaikum and hi everyone. In this video, you are going to learn the definition of first and second ionization energies. Then we will see the variations of the ionization energy across the period and down the group. Later, we will continue with definitions of the electronegativity, and lastly, we will see the variation of electronegativity of elements. So, stay with me until the end of the video. There are two types of ionization energies. We have first ionization energy and second ionization energy. So let's see what's the difference between these two ionization energies. First ionization energy refers to the energy required to remove 1 mole of electron from the outermost orbital or valence orbital in 1 mole of neutral gaseous atom. So, ionization energy yang pertama ini merujuk kepada proses yang memerlukan energi untuk remove, untuk kita buang sebanyak 1 mole of electron from the outermost shell or from the valence shell of 1 mole neutral gaseous atom. We can see the process from this equation. So, here we have 1 mole of neutral gaseous atom because it has no charge over here. So by removing 1 mole of electron from this 1 mole of gaseous atom, so hence you will get gaseous cation. Kenapa dapat cation? Sebab kita buang elektron. Buang berapa banyak? 1 mole of electron. Okay, so that's why electron will be on the right side of this equation. And the enthalpy of the reaction is positive. So this positive value menunjukkan bahawa energy is required for this process to occur. So in order to remove 1 mole of electron, we need to supply energy for this gaseous atom so that electron can be removed from the neutral atom. So here is the gaseous atom. So by supplying the energy, this atom can simply remove its 1 mole of electron to form the cation and electron. Second ionization energy is the energy required to remove 1 mole of electron from 1 mole of positive ion in gaseous state. So second ionization energy is actually the continuation of the first ionization energy. In the first ionization energy just now, we have gaseous atom. So after this gaseous atom remove the electron, you will get gaseous cation and electron released from the reaction. So by having the same gaseous ion here, we are about to remove another 1 mole of electron from this gaseous ion. Okay. So from this gaseous ion, so now we are going to remove another 1 mole of its electron. Okay, so after removing 1 mole of electron, so hence the product will be X2+. The positive charge will be increases. Okay, and plus electron that has been released just now from this gaseous ion. So this is so-called second ionization energy. So second ionization energy adalah continuation, penyambungan, okay, sambungan daripada first IE tadi. So untuk ionization energy, we can have many steps of ionization energies. We can have third ionization energies, fourth ionization energies and so on. So peringkat-peringkat itu kita panggil sebagai successive ionization energy. Okay, so di mana dalam successive ionization energy ini, produk yang terhasil daripada sesuatu ionization energy akan kita keep doing another process of ionization energies. Okay, so in all process there, we are going to remove another 1 mole of electron. Kita akan buat benda yang sama, proses yang sama, iaitu buang 1 mole of electron. So, the concept of ionization energy is about to remove electron from the valence shell. There are 3 factors that can affect the ionization energy. We have atomic radius, effective nuclear charge ZeV, and shielding effect. So, IE is about the tendency to remove electron from valence shell. The first factor is atomic radius. So for atomic radius, larger the atomic radius, attraction between nucleus and valence electron will be weaker and IE will be lower. IE lower meaning that energy required to remove electron is lower. So this means the process of removing the electron will be easier. So untuk larger atomic radius, untuk atom yang bersaiz besar, we can see that the distance between this nucleus and its valence electron at the outer shell here is in higher distance. Okay, jauh antara satu sama lain. So bila jauh antara satu sama lain, so we can say that the attraction between them will be weaker. So bila attraction between them is weaker, maka this electron can easily remove from the system. Okay, so according to IE adalah energy yang diperlukan. Okay, energy required to remove this electron. So apabila elektron ini mudah untuk keluar, bermaksud tenaga untuk IE akan jadi rendah. Second factor will be effective nuclear charge, ZEF. So what is ZEF? You have learned this before, right? So ZEF is about the attraction force between the nucleus and valence electron. If you still remember, ZEF is one of the factors that affecting the size of the atom. The higher the value of ZEF, or the more positive the value of ZEF, the atomic radius and ionic radius will be decreases or getting smaller. So let's apply the concept into ionization energy as well. So by having higher effective nuclear charge, meaning that the value of ZEF is more positive. So hence here, what happened is the attraction forces between valence electron and nucleus will become stronger. So bila tadakan itu kuat, apa yang akan jadi? Elektron akan pull closer to the nucleus. So apabila elektron berada dalam kedudukan dekat dengan nucleus, adakah we can simply remove this electron easily? The answer is no. So that's why ionization energy will be higher. Next factor is shielding effect. So for shielding effect, higher the shielding effect, meaning that greater distance between this valence electron to the nucleus. So in this greater distance, the attraction between nucleus and valence electron will be weaker. Bila kedudukan di antara valence electron dan nucleus ini jauh, so daya tarikan between these two will become weaker. So, apabila tarikan ini dah menjadi weaker, can we easily remove this electron from the valence shell? The answer is yes, sebab this valence electron is less attracted to this nucleus. So adakah proses to remove this electron require greater amount of energy? The answer is no. Lower energy required to remove this electron, memandangkan attraction between these two has become weaker. So lower the IE. From these three factors, we can conclude that the energy that required to remove electron from the valence shell, that is IE, is actually dependent on the strength of the attraction forces between nucleus and valence electron. So, the closer the distance between the electron, valence electron and nucleus, the stronger the attraction between nucleus and valence electron. So, we can say that it is harder to remove this electron. Okay, bila kedudukan di antara elektron, valence elektron dan nukleus ini dekat, so daya tarikan antara dua-dua ni adalah sangat kuat. So bila kuat bermaksud it is harder, susah untuk kita nak remove this electron. So the process to remove this electron must require greater amount of energy. So higher the IE. So in the other words, we can say that IE is actually the energy required to overcome the attraction forces between nucleus and valence electron so that we can remove this valence electron from an atom. So you have understood the three factors that affecting the strength of the ionization energy. So now we are going to apply the concept in discussing the variation in the first ionization energy across a period. So across a period meaning that moving from the left to the right of the periodic table. So across the period, proton number will be increases. So when proton number increases, surely ZEF will be increases. I hope you still remember what you have learned in the variation of the atomic radius. So bila ZEF increases, ZEF meaning the attraction between nucleus and valence electron. So when ZEF increases, surely the attraction between nucleus and valence electron also will be increases. So hence, atomic radius or atomic size will be decreases. Bila size dah kecil, bila size atom adalah kecil, maksudnya it is harder to remove the valence electron. So IE will be higher, meaning that greater amount of energy will be required in order to overcome the attraction forces between this nucleus and valence electron. Okay, so the energy is actually the IE. So bila IE ni boleh mengatasi this daya tarik kan, maka this valence electron can be removed from its atom. So that is the function of the IE, energy required to remove 1 mole of electron. Now, we are going to discuss the variation in the first ionization energy going down a group. Kita akan tengok bagaimana perubahan nilai IE menuruni sesuatu kumpulan. As we go down a group, principal quantum number N will be increases. So apabila principal quantum number increases, you should expect we have many inner electrons. So by having many inner electrons, definitely shielding effect will be increases. So this shielding effect akan menyebabkan attraction between nucleus and valence electron becomes weaker. And hence, atomic radius or size will be increases. So, seems the distance between nucleus and valence electron here now is farthest from each other. So, attraction between them pun akan menjadi weak. So now it is easy to remove the valence electron. Adakah this process require greater amount of energy to remove the valence electron? The answer is no. Kerana kedudukan dah jauh, attraction pun lemah, maka first IE will be decreases. Electronegativity. Electronegativity is the relative tendency of an atom to attract electrons to itself when chemically combined or bonded with another atom. In a simple word, electronegativity refers to tendency of an atom to attract the bonding electrons to itself when it is still chemically bonded with another atom. Okay, keupayaan untuk sesuatu atom menarik bonding elektron ke arahnya apabila dia masih dalam keadaan mempunyai chemical bonding. So as you can see in this image, we have two atoms, atoms A and atoms B, and they are holding a rope here. So this rope refers to chemical bonding, and the two circle here refers to, the two spheres here refers to bonding electrons. So now this is actually the example of a molecule, and in this molecule we have two atoms that is covalently bonded. Okay, yang mempunyai chemical bonding iaitu covalent bonding contohnya. So now this atom, okay, atom yang sebelah biru ni, so this atom are pulling the electrons, the bonding electrons towards itself. So ini menunjukkan bahawa this atom will has the highest electronegativity. Okay, kerana this atom has higher tendency to attract the bonding electrons to itself. As you compare to this atom pula, okay, this atom did not pull the bonding electrons to itself harder like what have been done by the atom B. So we can say that this atom A has less electronegativity rather than atom B. Atom with strong attraction for bonding electrons will have high electronegativity. So we have seen from this example just now, okay, this atom pull the bonding electrons to itself greater than this atom. So we can say that this atom will has stronger attraction for the bonding electrons, and thus it will has high electronegativity value. And the most widely used scale for electronegativity adalah the one yang developed by Linus Pauling. So he assigned the most electronegative element that is fluorine, okay, which has the value of 4.0 for electronegativity, and he also worked out for the others relative to the fluorine. To see the variation in electronegativity in the periodic table, so we will study the case of across the period and also going down a group. Now, let us study the variation in electronegativity across period 2 and 3. But before that, let's recall what is electronegativity. Electronegativity is the tendency to attract bonding electrons to itself, keupayaan untuk menarik bonding elektron ke arah dirinya sendiri. So, kita should expect atom yang boleh menarik bonding elektron ke arah dirinya dengan baik, maka electronegativity-nya will be increases. So, across the period 2 and 3, which means as we move from left to the right of the periodic table, proton number will be increases. So ingat, bila proton number increases, effective nuclear charge ZeV also will be increases. So apabila ZeV tinggi, iaitu becoming more positive, maka we should expect that the attraction between nucleus and valence electron will be increases. So stronger attraction between these two will cause the atomic radius or size will be decreases. Okay, size of atom akan mengecil. So bila size atom itu mengecil, maka ability of atom to attract the bonding electron to itself will be increases. So hence, electronegativity will be increases. Now, let's see the variation in electronegativity down a group, menuruni kumpulan. So, as we go down a group, we can see that principal quantum number will be increases. So, going down a group, principal quantum number n will be increases. So hence, when we have many inner orbitals like this, so we should expect shielding effect will be increases. So by having a stronger shielding effect, the attraction between the nucleus and the valence electron will becomes weaker. Attraction is weaker. So hence, apabila this valence shell and valence electron is less attracted to the nucleus, atomic radius or size will be increases. So now, the ability of the atom to attract bonding electron to itself will be weaker. Okay, so why it is weaker? Kerana kedudukan nucleus dan valence orbital here adalah jauh. So apabila jauh, these electrons has less tendency to attract the valence electron and also the bonding electrons to itself. So electronegativity will be decreases. The smaller the ionic radius, so as the atomic size getting bigger, ability of this nucleus to attract bonding electrons to itself will be weaker. Electronegativity will be decreases. This is the electronegativity scale that had been developed by Linus Pauling. And as you can see in this image, we have fluorine with 4.0 electronegativity value. The highest value of electronegativity is for fluorine. Okay, it means that fluorine has the highest tendency to attract the bonding electron to itself. So here we also have the other values of electronegativities for respective elements, and these values of their electronegativity is actually related to or relative to the value of the fluorine. So electronegativity has no unit. Okay, tak ada unit untuk electronegativity value. So as the conclusion of what you have learned in the previous slide just now, okay, going down a group, electronegativity will be decreases. Okay, anak pernah turun ke bawah going down a group. And when we go across the period, electronegativity will be increases. So for the summary, we have discussed the trend of ionization energy and electronegativity for the case across the period 2 and 3 and going down a group. And we have used these three factors. They are effective nuclear charge, shielding effect, and atomic size in explaining the trend in ionization energy and electronegativity. So please do your self-revision once again to make sure which are or is the factor that we should use in explaining these two trends, ionization energy and electronegativity. So I wish you all the best and have fun in your learning.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning, and remember, chemistry is easy and fun.